what is the energy of a photon that has a frequency? So we're looking at the energy of one photon that has a frequency of 4.5 times 10 to the 14 hertz. Okay, so we're looking for E is equal to then H times F. We can use that formula. So the H I can choose can be either one. Okay, either one you are allowed to choose. You just have to be mindful of your units. So say I use H is equal to 6.63 times 10 to the negative 34 joule times seconds. Okay, so that's my H. So now E is equal to 6.63 times 10 to the negative 34 joule times seconds times by 4.5 times 10 to the negative, or to the positive 14 hertz. Now if you think about it, hertz is like 1/2. So I'm just gonna, just to show how the units cross out. So here now, it's like the seconds cross out, and I'm left with joules. So then you put that in your calculator, and you get 2.9835 times 10 to the negative 19 joules. So to 2 sig digs, we have 3.0 times 10 to the negative 19 joules. So then it says, what part of EMR does this photon belong to? So you got to think back to kind of your spectrum and think about the joules, or the energy of each. So this type of energy, if you look at your chart, this applies to the visible spectrum. So the energy of visible light that we can see. Next, a beam of monochromatic light, so like either red or blue or green, okay? In this case, 580 nanometers, 580 nanometers. That's probably like bluish. The beam delivers 910 electron volts. So a whole beam, so that's like E total, is equal to 910 EV per second. Okay, so per second it gives us that. Okay, determine the and we know our wavelength is equal to 580 nanometers. Determine the number of photons incident on the detector each second. So number of photons per second. So what we need to think is our E is equal to N, or E total, N times H times C over lambda. And I'm looking for N. I want to figure out the number of photons. So I'm going to rearrange to solve for N. So N equals E total times by, I'm not going to use multiply by, is times by lambda divided by H times C. Now the H that I'm going to use is the H that has EV in it, because I want to be able to cancel out these EV. So my H is 4.14 times 10 to the negative 15 EV times seconds. Okay? So now N is equal to 910. You know what? I'm gonna need to scroll down. This is too crammed. So N is equal to 910 EV per second times by 5.80 times 10 to the negative 7 meters divided by 4.14 times 10 to the negative 15 EV per second multiplied by 3.0 times 10 to the 8 meters per second. So if you think about it, these meters will cross off. We will have like these EV will cross off, so this seconds is on the bottom and that one's on the bottom, so we'll have one of the seconds crossed off. Yeah. So what we'll be left with when we put this all in is n is equal to 424.9597, etc. second inverse 1, because they'll still have 1 second on the bottom. So I think that these it's these seconds that cross off there. Okay, so now I have 425 photons per second. And that's the answer. So now you can work on your workbook questions.